All right, part two here. So the first one here is an algebra proof. Yours tomorrow is going to be this intense. You're going to have to set up some sort of equation using like a geometry situation, maybe something like this. Where you're going to have to create why the angles are equal, that type of thing. For our purposes, though, for our intents and purposes here, we're going to do this as just an algebra proof, so we get the idea here. So what I would want you to do normally, and I would advise, is on the side you go solve it. Okay. So if we take a look at this, 2 times the quantity x minus 1 equals x plus 1 squared minus 2x times x plus 1. So how would I normally do this? Well, I would obviously, the next step would be to distribute here, okay? And then also I have this x plus 1 squared, but really what that means is I'm doing x plus 1 times, right, x plus 1. And so when I do that, what happens? Well, if I distribute the x through, I get x squared plus x, and then I distribute the 1 through, I get another x, and then I get a 1. So this really turns into x squared plus 2x plus 1. Okay, that's what this is. It's not just squaring the terms together, so x squared and 1 squared. It's multiplying and distributing, right, an x plus 1 times another x plus 1. So we'll move through. So 2 times x, 2 times negative 1, that's 2x minus 2. This thing is going to become x squared plus 2x plus 1, which we just talked about out there. And when I distribute the negative 2x through, I'm going to get minus 2x squared and then minus 2x. So I'm just going to combine like terms from here, okay? So we'll see if we can make that a little bit bigger for you to see. All right? So I have a minus 2x and a positive 2x. Those are going to cancel out and they're going to drop out. This 2x minus 2 is not going to change. It's the only thing on that side of the equal sign here, on the side of the equation. And I'm left with x squared minus 2x squared, so that's negative x squared, and then just a positive 1. Okay? So first step, we want to get everything on the same side, and we want this x squared to always stay positive. When we factor, we want this positive, so let's do it now. So we're going to move all of this junk that way, so we can get the x squared positive. So we'll add x squared to both sides, which can't combine with anything here. And we're going to subtract 1, which will take away from the negative 2. So in standard form, we have the x squared first, then we have the plus 2x, then we have minus 3 is equal to 0. So we're going to factor it, so 2 sets of parentheses, and if you want to use the triangle, the diamond here, go ahead. So it should be multiplying to negative 3 and adding to 2, so that would be positive 3 and negative 1. So it's x plus 3, x minus 1 equals 0. And then I do the 0 product property. So x plus 3 equals 0, or x minus 1 is equal to 0. And I get my two answers of negative 3 or positive 1. Okay? So now I'm going to take this work and put it into a proof. So we'll start with our 2 columns. We always do statements and reasons on the top. Okay? And then the first one is always the given. Okay? Then my next line I did was after the given, I distributed and I got this. So the next line should be 2x minus 2 equals x squared plus 2x plus 1 minus 2x squared minus 2x. And that is just from distributing. So we're going to put distributive property. I definitely spelled distributive wrong. That's okay. Distrib, T-R-I-B. There we go, close enough. All right. Next, we combine like terms. So we ended up with 2x minus 2 equals negative x squared, and then plus 1. So this would be either combine like terms or substitution. Then I moved everything over on this side. So I ended up with x squared plus 2x minus 3 is equal to 0. So that was just either addition or subtraction property of equality. It doesn't matter which one you put down. Okay, then we factored it. So we got x plus 3 and then x minus 1 equals 0. And we could just put down factoring or the distributive property again. Then we use a zero product. And then we just solved. And notice, same thing. So we're good to go. And once again, either addition or subtraction, doesn't matter. Property of equality. And there you go. All right, there's your algebra proof. Okay, so slide down to number 9 here. Okay. And on number 9, we want this 3 to use this 3 over here. Okay, the answer is actually a 4 and 3 on this side, but we'll just keep them here for our job here today. So, all right, so I know that L is parallel to M. Okay, and I know that angle 2 is the same as angle 4. And my job is to get N parallel to P. Okay, so we want to try to think about how those angles are going to be equal to each other. All right, so if L is parallel to M, what do we know? Now the link between these is that these should be equal to each other, right? And actually, you know what? We actually want this 3. So I apologize to everyone in class. We get this 3. We're going to be in business here. We want 4 to be over here. So if you look at your solution sheet, and I gave you guys, most of you guys, you got this in class. So the 4 and 3 are here and here. So this is where we want the 4 and the 3 for our class here. So sorry about that. Watching the video, make that change. All right. So now let's take a look at it. So we know that these two angles are equal already. We want to get these two lines equal. So really what we need to show is that this angle is equal to 3 and 4 are the same. Okay? So I can't just say, well, look at these are corresponding and we're good to go. Because I don't know, well, I'm trying to show these are equal, so time out. If these are parallel and we know it, we know that these two angles are going to be the same because they're corresponding. I can't just immediately say, well, 3 and 2 are alternate exterior, they have to be equal. Because I would need these lines parallel first to make that happen. Okay? So first we need to get 4 and 3 equal, and then we can use the fact that 2 and 3 are now equal and alternate exterior to show that the lines are parallel. So that's the plan of attack here. Okay? So same thing as normal. Throw down statements and reasons. We do L parallel to M, and angle 2 is congruent to angle 4, and that's just given. Okay, 2. Now we're going to use the fact that these lines are parallel, so that's our key word. So we're going to look at the parallel part to get angle 4 congruent to angle 3. Remember, any parallel reason we're throwing down starts with the 2 parallel lines cut by a transversal. Okay, we fill in the vocab word. 4 and 3 are corresponding, so corresponding angles are equal. Okay, or congruent, and we're good to go. Now, since these are corresponding and congruent, I can tell you that these two lines, N and P, have to be parallel because these alternate exterior angles are equal. Same thing, parallel line reason, starts off with 2 parallel lines cut by a transversal. And then fill it out. Alternate exterior angles congruent. We're done. All right? Good deal. All the way to the back. This last proof is another geometry proof. This would be something similar to what you normally be asked to do on an exam. And this is a great, or on a test we have. This is a great example of the angles adding together, creating one simple equation, and then subtracting up to equal to each other. So, start off like normal. We throw down our statements and reasons. The first reason is always given, and we're always copying down whatever it says in the problem for given. So it's just AB, that line segment, is going to bisect angle ECD. Now, keyword time. Keyword here is bisects. What are you bisecting? Angle ECD. Remember, we used the example. If I bisect a watermelon, does it mean that I get cut in half? No, the watermelon does. So whatever follows that word bisects is getting cut in half. Here's ECD right here. So if I cut it in half, I'm going to get these two angles, which are going to be equal. All right, so angle ECB is going to equal or be congruent to angle DCB. 2, how do we know that? It came from that keyword bisects, so it's the definition of an angle bisector. All right, good deal. Now, how are we going to get these two angles out here to be equal? And it's off of the fact that these are making a straight line and they're making a straight line, okay? So we want to build an equation to get these angles in there and then subtract away these two congruent ones. So we're going to say that angle ECB plus angle next door to it, ECA, is equal to 180. And the same thing on the bottom. So DCB, that angle, plus the angle on the other side, DCA, is equal to 180. This is just supplement your angles or anything about angles on a straight line. Add to 180. You can also use linear pair here. Okay, supplement your angles, any one of those things. All right. From here, we want to set these two equations equal. So angle ECB plus angle ECA is equal to angle DCA plus angle DCB. Okay, that is just going to be substitution. You can also put down the transitive property here if you want. All right. And now, remember from the given, we knew that from step 2, we knew that angle ECB and DCB were equal. So we're going to subtract those two away, and we'll get left with angle ECA, or angle ACE, as it is here, is going to be equal to that measure, angle ACD, or DCA. And we do want to go back and throw these m's in, we remember, because we're dealing with 180 degrees, as opposed to the angles themselves here. All right, and then the reason for that for step 5 is just subtraction property of equality. We're good to go. All right, that's the last one. There you go, one more time. All right, I'll see you guys tomorrow. Study up. Remember, you're looking over for your proofs, your statements and reasons. You're looking at some basic constructions like bisect a segment, bisect an angle, perpendicular bisector, equilateral triangle, those type of things. You are looking over your angle pairs for parallel lines. What are the angles called that are on the parallel lines cut by transversal? Which ones are going to make the lines parallel? Which ones aren't? Kind of like that question we did earlier over here. Okay, stuff like that too. So study up. Good luck. See you tomorrow.